much, Jay, and good morning to everyone. So yeah, I work at IDC and I focus primarily on storage systems there, and since what's been happening that's of interest in that arena over the last 8 years has been mostly around solid state storage, I spend a lot of my time doing primary research and other activities associated with that and how solid state fits into systems. So let's take a look first at how this market has grown. At this point, external enterprise storage is roughly $25 billion in revenue. And you can see that since the first NVMe-based all-flash arrays started shipping in 2016, we've already gotten to the point where it was roughly a $1 billion market in 2018. Now, what's sort of interesting about this is if you think about this comparatively to when the very first all-flash arrays started shipping back in the 2010, 2011 timeframe, it took about 5 years before all of the established vendors had comparable offerings in that space. A few dribbled in a little bit earlier, but it was primarily startups for the first 3-4 years. This change was collapsed significantly in this NAFA space, NVMe-based all-flash arrays. So the first types of appliances that shipped with software, NVMe integrated, as a system ready to deploy, were in 2016. You obviously could put NVMe SSDs into your own server-based storage, but the first appliances really came out from startups in 2016. And by 2018, NetApp, IBM, Dell EMC, Pure Storage, and Hitachi all had NVMe-based systems that they were selling. So the majors got into the space very rapidly. Most of that $1 billion in revenue is actually coming from those companies shipping their flagship products in NVMe-based versions. And for 4 of those 5 vendors, not Hitachi, but the other ones basically had a flagship SCSI-based all-flash array. They took that system, kept the same software, integrated NVMe into it, and shipped both a SCSI and an NVMe-based version of those systems. So those systems were mature, proven, had a lot of software functionality on them. Startups, on the other hand, were focused a lot more on software-defined storage designs. They were leveraging COTS hardware, commodity off the shelf. It was a much less expensive purchase than buying something like an EMC PowerMax or a Flash Array X from Pure. And they were also targeting a little bit of a different market space, which we're going to talk about here in a second. But I want to make a couple more comments about the market overall and the revenues. So the overall external storage space is not growing very fast. Okay, you can see the top line revenue there. It looks roughly the same. It's about a 1 to 2% growth rate. However, there are segments of that market that are growing extremely fast. And the fastest growing segment in that space these days is the NAFA market, which is growing at 67% CAGR over the next 5 years. Some of the other high growth segments in that arena are hyperconverged infrastructure systems, and those are growing in the 25% a year arena. They're not listed on this slide here on the left-hand side, but that's another extremely high growth market that we're seeing. And there's going to be some interesting new technology infusions in that space with the advent of NVMe TCP that we'll talk about a little bit later that I think are going to give a boost to that HCI market, that hyperconverged arena. In this external space, you can also see that the older designs, the SCSI-based all-flash arrays, the hybrid flash arrays, and the HDD only, are all pretty much on the decline. So all the growth in this space is being driven by the NAFA products. So the transition from SCSI to NVMe in these systems, we think this is going to happen very rapidly. In fact, by 2021, over 50% of the revenues for primary external storage arrays, so external storage arrays that are shipped for mission-critical primary workloads, latency sensitive, are going to be generated by NAFA systems. And again, that's very surprising when you think about how long the shift from SCSI-based HDD arrays to SCSI-based all-flash arrays took. So I don't think anybody doubts that this is going to occur. The only question is, how fast will that happen? And from other analyst groups, you may see forecasts that show it happening a little faster or a little more slowly. This is our prediction as IDC, but clearly it's happening very rapidly. In fact, the other interesting point here is, so the primary storage arena that I'm talking about on that top quote, the by 2021, that's about a third of the capacity that ships in the overall external storage space. So secondary workloads, backup archive, other cold storage, that's about 2/3 of the capacity in that space. Primary is about 1/3. But NAFAs will grow to account for over 50% of all the revenues generated in that space. So not just the primary, but all the revenues in that space by 2023. So we actually see the use of these technologies integrating into secondary workloads that don't necessarily require low latency like the primary workloads do, but the ability to move very large data sets quickly, throughput, bandwidth, those are important in those spaces. And we've already got a couple of startups that are playing in that arena. They've got flash-based SSDs, NVMe options, although some of those systems offer a tier of NVMe and a tier of SCSI. But we are starting to see that happen already. Not much revenue in that arena yet, though. Okay, so why do people deploy NVMe? Well, initially, when the market started in 2016, this was pretty much all about two issues, latency and throughput. And there were very specific workload types that people used these on. Workloads that we refer to as next generation application design. So this was real-time big data analytics, artificial intelligence, and machine learning apps. So these were environments that were latency sensitive. They had very large data sets behind them. So there were concerns not only with the real-time response, but also the ability to run through massive data sets that were sitting behind these environments and give some sort of a timely result. Some of the other areas where we see this deployed, so if you look at web infrastructure players like Facebook, Google, Amazon, they all offer an NVMe performance tier. That's based on a pretty off-the-shelf, they buy NVMe SSDs, and they put them in Linux-based servers and make that part of their web infrastructure. We see social media platforms like LinkedIn also using this kind of data, in particular for the analytics that run behind some of the activities that those platforms are doing. And obviously in arenas like finance and other areas where we have transaction processing systems that are very sensitive to latency, and they can show a direct correlation between faster, more throughput, faster response, and revenues that get generated. That's where we've seen a lot of these get deployed. So finance, Wall Street, that was another area where we saw a lot of early NVMe starting to go in. There was sort of an arc to this evolution in the sense that people first started deploying NVMe for these kind of workloads by just buying NVMe SSDs and putting them in server-based storage. And as those workloads grew, they all pretty much got to the point where they said, what we really want is a high-performance NVMe SSD that we can share across a lot of servers. And so that was really the advent of these initial NAFA players. People like Aperon Data, E8 Storage, Accelero, Vexata got into that space, Pavilion Data. So those were the kind of people that came out with appliances that were pre-built for these environments and also offered storage operating system software that on the target side was more optimized for NVMe. It could better take advantage of the massive parallelization in NVMe. And if you look at how those systems performed relative to just sticking NVMe SSDs into a Linux server, there were some performance and latency advantages. They weren't huge, but there were clearly some differences there. We also saw some of these players in the external storage arena start to introduce some data services. Some of them offered RAID or erasure coding. Several of them offered HA configurations, not all of them. So they were starting to add some of those enterprise capabilities in that space. Now, what I think really over the course of the last year has led so quickly to the growth of revenues in this space, despite the fact that everybody's got a system now, there's a lot of these systems to choose from, the standards were maturing. One of the areas that was sort of an issue with the early systems was there wasn't a standard NVMe over Fabrics implementation available. So all of these early NAFA players had to have proprietary software drivers that sat on the server side. And so this was a concern for many of the web infrastructure players that wanted to deploy cattle, not pets. I don't know if you guys have heard sort of that distinction, but they wanted systems that were as off the shelf as they could get in terms of the software and the hardware, but they could still get the NVMe performance. And Peter Bushman from Bookings.com, he said this just so perfectly. I was chatting with him about this last year, and he had looked at a number of these NAFA players, and he said, yeah, we've brought several in, we've tried them out, we put the client-side proprietary drivers on, but he said, I have 50,000 servers in my infrastructure, and I don't want to have to treat a very small number differently that need that high performance. I want to be able to potentially connect every one of my servers up to these environments if and when I need it. And so what he was most interested in was NVMe TCP that ran with the standard driver set. He didn't have to buy a special converged Ethernet adapter to do that. And so we are just starting to get into the space now where there are companies like Lightbits Labs, Toshiba plays in this space. There's several other vendors that are shipping NVMe TCP implementations. So that's sort of, I think, the future of NVMe over fabrics. The lion's share of the deployments over the course of the next 2 to 3 years, we think is going to strongly favor NVMe TCP just because of the industry standard nature of it. Now, it's not quite as fast from a latency point of view as the NVMe over fabrics implementations that support RDMA, like, for example, Rocky, but they're standard, and Rocky still requires some proprietary components. So there'll be a little of that out there going forward. There's a lot more of it out there right now in terms of percentage, just because NVMe TCP wasn't available. But we think that's going to really drive things in this space. Vendor pricing strategies, it's also very interesting what happened here. So normally, when a vendor introduces a new higher performance system, there's a price premium on that system. Well, that was in fact what happened with the startups. If you looked at just buying a SCSI-based all-flash array built out of COTS hardware versus one built out of NVMe, back in 2016, there was about a 20-25% price premium on that, driven primarily by the hardware costs. The first major vendor that introduced an NVMe-based system was Pure Storage. So in May of 2017, when they introduced the Flash Array X, so that was the NVMe-based version of their older Flash Array M, they made a decision to price that at exactly the same price point as the SCSI-based array. So in that time frame, that probably had some margin implications for them, but their strategy here was they wanted to get NVMe into the installed base more rapidly, and also use that as a differentiator against their competitors, NetApp, IBM, Hitachi, HP, and Dell, who were not yet shipping systems like that. So we saw very rapidly the new shipments from Pure shifted over to the NVMe-based arrays. There was only one reason not to buy an NVMe-based flash array if you were a Pure customer, and that was if you had not yet certified that system and you didn't have the time to do it, but you needed to deploy another array. Those were the folks that were buying the older M's. Pretty much everybody else bought the X's. So by 2018, if you looked at their financials, over 70% of their flash array revenues by the end of 2018 were actually coming from the X system. So that swap over happened very rapidly. So about a year after Pure got into the space, we saw NetApp get into it, IBM get into it with their own versions of the system. These vendors initially had premiums, but IBM pretty quickly moved to the same pricing model that Pure had. And in fact, in their case, because the hardware they were using was built in-house, they weren't off-the-shelf SSDs, they actually could lower the price of an NVMe-based version of their array, and they could increase the margin. So they were sort of in a different position than Pure, who was using a lot more off-the-shelf hardware back in that time frame. Now, Pure has shifted a little bit in that strategy, but so IBM got into that very quickly. By the end of 2018, NetApp had also made the same change where they were shipping their two systems, SCSI and NVMe, priced at the same. So for a given performance level, a given capacity, that was what the comparison was based on. Dell EMC announced their version back in Q4 of 18, and they had a price premium, and in fact today they still have a price premium on the PowerMax. But the fact that so many of the vendors had gone to this pricing strategy where it was a no-brainer to buy NVMe, this has really helped generate the revenues in this space. And obviously, the availability of a number of options, just the maturity. So just briefly, what do we mean by a NAFA? So there's kind of three components. One is the array, which doesn't support SCSI. It's got NVMe controllers and devices, backplane. You've got some kind of components on the host that you can attach and talk to that system with. That could be a SCSI connection, as in the case of most of the majors. They introduced an NVMe system, and they planned to introduce an NVMe over Fabrics option later that could just be added on. And in fact, many of them have done that at this point. But the established players offered that SCSI or NVMe over Fabrics option. All the startups just went with NVMe over Fabrics. And in fact, it was pretty clear that Ethernet is the future in this space. So that was rocky, a little bit of iWarp. Now that's moving to TCP. The established vendors who had much larger installed bases of fiber channel SANs came out with fiber channel-based versions to make the migration easier for their customers, but they all have also introduced Ethernet options. And Ethernet clearly is the future in this space. One other little interesting wrinkle is with TCP now starting to become available, we're hearing vendors talk about a smart NIC that would help offload the TCP overhead on the server side. So kind of gives customers different options about how do they want to address the overhead, do they not care about it, and still not have to have some kind of a proprietary software load on the side of the system. Now, obviously, they'd have to buy the smart NIC, but that's going to be a little easier for them to manage than if they've got a software driver on there that they have to independently update. Okay, so those are the three components to these systems, how we identify them. And again, startups were all NVMe. The majors offered a SCSI connection option on their systems. The wide availability, so in addition to the vendors I already mentioned on the startup side, there's a bunch of other players, other startups that were basically just COTS hardware, not much software, companies like Radix. So there's a lot of those guys, but we don't see a lot of revenues from them in total. We've seen some consolidation in just the last couple of months with the startups. So E8 was bought last week by Amazon Web Services. And if you want to see our take on that, we are just about to publish a market note describing why we think that purchase happened and what it means for E8 customers. They've got an install base as well as AWS and E8 themselves. We also lost Vexata, who got acquired for a pretty low price by StoreCentric. That happened a month or two ago. And there is another well-known all-flash array vendor that is about to go out of business, and that'll probably become public in the next month or so. So the consolidation is starting to hit these guys. What's really happening with the startups is now that the majors all have an option, there are just a lot more sales headwinds for them to try to sell their systems because they're a riskier choice than buying from a NetApp or an EMC. Now, true, their systems deliver a little more performance, but anyway, they're starting to have some trouble in those arenas. The ones that are the most successful have focused on generating very effective channel sales strategies. Accelero would go into this arena, in my opinion, and they're also targeting a different workload set than what we see from the majors. So we're going to look at that in a minute. The majors, I won't go through all of them, but pretty much all the major larger companies are in there. Okay, so we did some research on people who had deployed NVMe in their environments at the very end of last year. So I want to share some of those data points with you. So first of all, we asked, why did you buy it? Not a surprise, performance. But you can see some of the other areas that are of interest. So increased infrastructure density. Keep that one in mind because when we look at the two deployment models, that one is going to become critical. So you guys will have access to these slides. I won't necessarily go through all of those other than to call out performance and infrastructure density. With performance, we wanted to ask another question, which is, well, what do you mean by performance? What aspects of performance are most important to you? And by the end of 2018, I think it's very interesting that low latency was only the 5th reason why people wanted to deploy NVMe. The highest reason actually had to do with more predictable storage performance. So with a lot of these real-time analytics environments, as their data sets continue to grow on the back end, the server-based storage designs that they had started with were starting to cause problems in terms of unpredictable spikes in latency. And moving to these NAFA systems was one of the ways that they could address that, because they could get a lot more storage capacity behind the controllers, in effect. And the server-based designs were more limited to however much storage you could fit into that server, and then you had to incur a network hop to get to other data behind it. So another thing, though, that came out high here, the increased infrastructure density, okay? And the number two, the throughput and bandwidth, that's primarily about the ability to move these very large data sets that in this big data analytics era, more and more companies are struggling with that issue. Okay, so why did you buy the particular platform that you bought? Well, performance again came out as the top issue here, but there were some other things that maybe aren't surprising. Ease of use, so the third one down from the top, that was the second most important reason for doing this. And it's sort of interesting, the one about wanting availability features. So you had vendors like E8 Storage who had specifically said, we're building a high availability version of this appliance. It had RAID, it had dual controllers, and there was redundancy built into the hardware. That wasn't necessarily true with the other options who were focusing primarily on performance. The types of next generation application workloads that these startup systems often got deployed for, many times they were developed in ways where the application itself managed its own availability. It had some kind of a replication or replica feature built into it. And again, to get back to the pets versus cattle, a lot of the larger companies, not only larger enterprises, but service providers and hyperscalers that were looking at these kind of systems, they didn't want to deploy specialized hardware. They wanted the cheapest kind of hardware that they could get the performance out of. So if you look at a lot of those installs, they didn't have redundancy built into a node. The node died, the software just reconfigured around it, and the system kept running. So that's sort of a dichotomy there. E8 went after a particular group where they needed that resiliency in the underlying infrastructure. Okay, very broad production use. So again, this survey was sent out to people who had NVMe in their environments. We didn't look for people who had production deployments. We just asked the question, do you have it in your environment? Like it might be in your test bed. High percentage of them were using this in production. And again, this was December of 2018, so at the very end of last year. Extremely high satisfaction rates with it. In fact, 95% almost if you look at very and somewhat satisfied. So that's nice to see. The two deployment models. So I'm going to finish on this slide because I know I'm getting to the end of my time frame, but I want to make the point here that there are really two very different workload sets that vendors are going after. The startups are going after that single application that requires this absolute performance they only get out of NVMe. The majors were using it more to go after mixed workload consolidation. So the pitch from somebody like Accelero would be, you want to run that real-time big data analytics app, place that on this dedicated system and you'll get the performance you need. Meanwhile, EMC, well not HP because they got into the game quite late with Primera, but Pure, HP, NetApp, their pitch was more, hey, you've got this SCSI-based all-flash array and you've got a certain workload density on it. We'll sell you a system that is actually going to be smaller in size, it'll deliver more performance, and you can put more workloads on it. So in other words, you could increase the consolidation ratio on that platform so you could bring more workloads under the management of a unified interface. And since those systems had defense in-depth availability capabilities built into them, concerns about fault domains, you didn't have the same kind of concerns on something like a NetApp A800 or an EMC PowerMax that you might have on one of the startup NAFA systems. So this dichotomy continues to exist as the majors sell more and more of their NAFA systems. I think we're going to see the startups, get more and more pigeonholed into specific workload types where they've been able to succeed in the past, so they can start to generate a beachhead around a particular application arena. But it is definitely becoming harder for startups to sell in this environment, given that all the majors are in there. And again, that took less than 2 years. Okay, so there's a few more slides. You'll have access to this stuff. So let me stop there in the interest of time.